We're going to get started here with quadratic equations, but we're going to start with an application problem. So let's draw a picture. Let's say we'll draw a picture here, and of course here's a building, and let's say this is a 6th floor up here, and forget about it. Anyway, there's a man up here on the building. What is he doing? What's he have in his hand? What color should we make him? Orange? Let's make the man orange. So there's a man up here. Man, woman, I don't care. Somebody's up here. And they are going to drop a ball. Let's say that it's purple. A purple ball. They're going to drop this purple ball, and it is going to, let's say here's ground level. We've measured the height from the distance from the okay, that's not a straight line, but it should be. We measured this distance to be 100 feet. Or you could say, I don't know. Yeah, you could say 100 meters, even though 100 feet's not equal to 100 meters, but you could say it's 100 meters. It don't matter. Okay? Whatever you want to do there on that. What we want to know is, how many seconds is it going to take for the ball to hit the ground? Okay? So this is what we're looking for. T is the question mark, and it's in seconds. Okay, it's in seconds. Here's the model that we're going to use. The height is equal to negative 16 t squared plus 100. Okay. Now you might be asking, where in the world does this come from? Don't worry about that right now. However, you can see that this 100, there's 100 over here, right? Actually, this is in feet per second, isn't it? Since it's 16, yeah, we better do that. Anyway, okay, so it's going to be in feet per second. So this models the distance. When we plug a number in for t, for example, at 0, when t is 0, okay, negative 16 times 0, 0 plus 100 is 100. So at time 0, the ball is 100 feet from the ground. Now we're dropping it straight down, okay, and we're just dropping it. We're not throwing it down. Then it's a different problem. So what time, how long does it take for the ball to hit the ground? I remember when I was first learning this stuff, first thing I did is I went to the bridge and dropped my keys off of it and timed it. And it turns out that this stuff's actually fairly accurate. This model is. So when time, what time is it when the height is 0? So we're going to let the height be 0. See that? The height will be 0. So the ball, okay, let's say when the balls are falling. It's falling. And when the height is 0 is when the ball is basically on the ground. Okay, the ball's on the ground when height is 0. So what we want to do in this equation now is we want to solve for t. Okay. So let's take a look at that. How are we going to solve for t? Well, the best thing to do here is let's factor out this negative sign. Okay, I want to do that first. Let's factor that out. So 0 is equal to, let's factor out a negative 1, I guess you could say. And we'll be left with 16 t squared plus 100. Now I want you to think back at when we were factoring binomials, because this is a binomial now. Remember when we were factoring binomials? Does anybody remember that? I'm going to rewrite this as 4t quantity squared. 4t quantity squared plus what? Plus something's fishy here. And I'm trying to figure out what it is. When I factored that negative out, I didn't make that. That should be a minus sign right there. Okay. So you probably saw it and forgot to tell me. And that's actually going to make that. Okay. 10 squared. Okay, this was in the section we factored binomials. What do we have? This can be factored now as 4t minus 10 times 4t plus 10. See that? If you multiplied these two together, you should get 16t squared minus 100. If you don't, something's fishy. Okay, of course you will if you're copying this problem down. Now what we want to do is we want to set each one of these factors equal to 0. So let's do that. 4t minus 10. So that's the first one. Now this goes back to solving linear equations. So you see how all this stuff's building on each other? Goes back to solving linear equations. So we take we add 10 to both sides, right, and multiply through by 1/4. Okay, so we got t is equal to 10 over 4, which is I'm going to say approximately, but actually I think it's 2.5 seconds. 2.5 seconds. What about this one? Right, we got to set that equal to 0 also. But when we set that equal to 0, what do we get? We get negative 2.5 seconds. Okay, we get negative 2.5 seconds, and we want to go with the positive 2.5 seconds. Okay, so we go back up here. So how long does it take? When he drops the ball and they time it, it's going to take 2.5 seconds. All right, 2.5 seconds. That's pretty cool, isn't it? That's pretty cool. All right, so we got a ton of problems to work. I think I'll go into maybe what is a quadratic equation if you happen to see one on the street and can identify a quadratic equation. All right, that's what's going on next. We got lots of problems working this section, and I'll see you there.